connecting your world.
You sit down to work and your connection drops. That tiny RJ45 cable pops loose or silently fails, and your workflow stops. We are going to restore your internet access. We will start by testing the physical cables, move through deep-level Windows driver and registry resets, and finish by diving into the BIOS to resurrect unresponsive hardware. Step 1 is a simple baseline test. Grab your phone, turn on its Wi-Fi, and check if it can load a web page through your home network. If your phone connects to the Wi-Fi, you know the internet is reaching your home, and the router's internal modem is active. This narrows the failure point down to the local connection, either the physical LAN hardware or the PC itself. Now inspect the physical Ethernet cable. Check the entire length for deep kinks or frayed wires, and look closely at the printed text on the jacket to see if you are using a standard Cat5e or Cat6 cable. Next, look closely at the Ethernet port on the back of your computer while the cable is plugged in. This diagram breaks down the status LEDs you should see. A solid green light means a stable physical connection. A blinking green light indicates active data transfer. An amber light points to a slower speed or minor configuration error. If the port is completely dark, your computer isn't recognizing the hardware handshake at all. To rule out hardware degradation, perform the bypass test. Plug your cable into a different port on the back of your router. If nothing changes, swap the wire for a known working spare cable. Unplug both your router and your computer from the wall for 30 full seconds, then power them back on. You have now swapped the cable, tested a new port, and cleared the short-term memory of both machines. We have established a clean electrical baseline, ensuring that any remaining issues are strictly software-based. With the physical hardware cleared, let's look at the operating system. Run the built-in Windows Network Troubleshooter to see if the system can repair its own configuration automatically. If the troubleshooter fails, click the Start menu, type CMD, right-click Command Prompt, and select Run as Administrator. Watch this command line. Type ipconfig/release and press Enter. This strips your computer of its current, potentially invalid IP address. Next, type ipconfig/renew and press Enter to request a fresh, clean IP address directly from your router. Now type ipconfig/flushdns and press Enter. This clears out the locally saved website addresses that might be routing your traffic to dead ends. Finally, type netsh winsock reset and hit Enter. Winsock is the internal programming interface that dictates how Windows software handles network requests. This command forces a hard restart of that entire language center. By releasing the IP, clearing the DNS, and resetting Winsock, you have purged specific network configuration data that often blocks incoming connections. If the connection is still down, the driver itself may be corrupted. Right-click the Start button, open Device Manager, and expand the Network Adapters category. Look for your primary Ethernet adapter. You are specifically checking for a yellow triangle warning symbol next to the name, indicating a driver failure. Right-click the adapter and select Uninstall Device. Deleting your hardware components feels dangerous, but it is entirely safe. Once you uninstall the adapter and reboot your PC, Windows will automatically detect the missing hardware and install a clean, factory default driver in its place. Once your computer restarts, go back into Device Manager. Right-click the newly installed adapter, select Properties, and open the Power Management tab. Look at this Properties window. You need to uncheck the box that reads Allow the computer to turn off this device to save power. Windows frequently attempts to save energy by putting network cards to sleep during idle moments, but poorly written drivers often fail to wake them back up. Disabling this setting forces the card to stay active permanently. While you are in the adapter settings, navigate to the Advanced tab, find the Speed and Duplex property, and force the value to 1.0 gigabits per second full duplex. This prevents the adapter from incorrectly auto-negotiating down to a slower, broken connection. Next, open your Windows network settings and manually assign your DNS server to 8.8.8.8. This routes your traffic through Google's public servers, bypassing any localized failures at your specific internet service provider. If you still don't have internet after a clean driver install, we have to look beneath Windows entirely and examine your motherboard's BIOS. Restart your PC. As the screen powers on, repeatedly press the F2 or delete key to enter the BIOS interface. Navigate through the menus and look for settings labeled onboard LAN or integrated peripherals. Verify that your motherboard's network controller is toggled to enabled. Save your changes and exit. If the port is enabled in the BIOS but the physical lights are still dark, your network card may be trapped in a locked electrical state by trapped flea power. To fix this, perform a static discharge. Unplug your PC from the wall, then press and hold your computer's physical power button for 30 seconds. Plug the system back in and turn it on. If the Ethernet port remains completely dark and unresponsive after draining the residual power, the physical port on your motherboard has failed. You do not need to replace your entire motherboard. Purchase a standard USB to Ethernet adapter and plug it into a high-speed USB 3.0 port. We have now verified your cable, your router, your Windows drivers, and your motherboard's firmware. If the connection remains dead, an external USB adapter provides a new hardware path that completely replaces the non-responsive onboard port. You followed a logical diagnostic path. You checked the external physical cables, executed deep-level command line resets, reinstalled the Windows drivers, and directly interrogated the BIOS layer. Look at this icon change. You now have that solid connected monitor icon back on your taskbar, or you possess the exact diagnostic proof required to buy a USB adapter. Leave a comment below with the exact step that brought your connection back online, so the next person watching knows where to focus their effort. Methodically eliminating variables identifies the specific failure point, replacing guesswork with a resolved connection.